Okay guys, we're starting our look at squares. This will be on the same set of guided notes as rhombuses. Now, hopefully we got through everything on rhombuses on Friday. And a rhombus, as you recall, is a special type of parallelogram. Just a little bit of review here. It is a parallelogram where all four sides are the same length. Okay? A square is very similar, with one small difference. If you recall on a rhombus, we said that these diagonals, let me draw a couple in, they were going to be bisectors. They were going to meet at 90 degrees. But they weren't necessarily congruent like we had with a rectangle. Well, a square is a very special type of quadrilateral in that it has the properties of both a square, of a rectangle, and a rhombus. So let's take a look at what all of that means. And if you look on the second page of your guided notes, you'll see a square there where we start to look at what exactly we have when we have a square. So let's just draw a square here on the board. Okay. Well, first of all, a square is a parallelogram. So we have all of those same properties of a parallelogram. We're going to have two sets of parallel sides. We're going to have opposite angles being congruent. We are going to have diagonals that are bisectors. We're going to have properties of rectangles, which means we're going to have 90-degree angles. So draw those in. We said a square was a mixture of a rectangle and a rhombus. So we're also going to have every side congruent. What do you think happens on the diagonals? Well, it turns out that, again, we have a merger of both the rectangle and the rhombus. So we're going to put in these diagonals right here. Hopefully this green is showing up good on the screen. Now, we said it had both. Think back, rectangles. The diagonals were congruent, meaning that from this corner to this corner, we had the same distance as from this corner to this corner. So we've got congruency. They're still bisectors, just like in any parallelogram. Like a rhombus, we're going to meet at a 90-degree angle. These are also going to become angle bisectors. Okay, so this angle and this angle are going to be the same. And at that point, it's a little bit intuitive that if this is a square, obviously this line is going to cut a 90-degree angle into two 45s. So use that first square on the second page of your guided notes. Draw in some diagrams. Make some notes about what is actually happening here. How does it affect the diagonals especially? Because that's one important thing to really keep straight. The other thing I want you to look at is I did kind of a short Venn diagram. I do want you to update your big master sheet. But the big thing to remember is we have rectangles, R-E-C-T, and we have rhombuses, R-O-M-B. A rhombus is going to have four congruent sides. A rectangle is going to have four congruent angles. So, the big thing to remember is a square is going to have both of those properties. Okay? Let's compare and contrast just a little bit. We said a rectangle has to have four congruent angles, but it does not necessarily have to have four congruent sides. A rhombus has four congruent sides, but not necessarily four congruent angles. Okay? The rhombus side angles, do not need to all be the same. Okay? A square is a special case where everything fits together. It has both of those properties. Well, this has an interesting property then when we try to figure out if something is a square. If we can prove that a shape is both a rectangle and a rhombus, we will have proved that it's a square. Keep that in mind as we start looking at coordinate geometry and things like that. Okay, let's look at some examples. We went over some of the the test for squares is it both a rectangle and a rhombus? So you'll need to look at one of your tests for rhombuses, one of your tests for rectangles, prove them. If you can prove both, it's a square. Okay, go to page 3 of your guided notes, and we're going to look at some examples. And we are going to start with coordinate geometry. You all love coordinate geometry. All right, let's look at an example here. Okay, let's start by copying down this example. We want to determine whether parallelogram JKLM, it has vertices of J, which is -7, -2, K, which is 0 and 4, L, which is 9 and 2, and M, which is 2 and -4. And we want to determine whether these coordinates, when we plot them, connect the line, connect the dots, make a rhombus, a rectangle, or a square. So, we know rhombuses, we know the diagonals meet at a 90-degree angle. So let's see here. We've got one diagonal. We are going to have the diagonal from K to M. And we're going to have a diagonal from J to L. So we have two coordinates. Can we use the slope formula? Absolutely. So remember, slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Pause the video for a second. Try to work out both these slopes. When you're done, restart the video and we'll go over to make sure you got the right answer. Alright, let's look at our slopes. Let's start with the slope of JL. Okay, we will have y sub 2, which is 2, minus a -2 from J. Negative and a negative, that's going to become plus. 9 minus a -7. Again, a negative and a negative becomes a plus. We have 4 over 16. So we have 1/4. So now we need to look at the slope for MK and see what we get there. So slope MK. All right, we start. We're going to do MK, so we got 4 minus a -4. And we've got 0 minus 2. That'll become a positive, so we've got 8 over -2 or -4. All right, let's remember to say if two lines are perpendicular, the slopes are going to be negative reciprocals. 1/4, -4. We've met that criteria. We know for sure that this is a rhombus. Great, but that doesn't tell us whether it's a square. We know it's a rhombus. To see if it's a square, we need to see if this is also a rectangle. Well, what do we know about the diagonals of rectangles? They're congruent. If we're finding congruency, we use the distance formula. Okay? Now, remember we've determined a rhombus. I'm going to erase this part. Have a little room to work. So we want to compare the distances now on MK and JL. So, pause the video again. Use the distance formula. Find the distance from J to L and the distance from M to K. Pause the video, see what you get, and we'll check the answers. All right, let's see what we get. So we want our distance from J to L. So we have the square root of x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. Both of those are squared. All right, let's plug in some information here. So the x value for L is 9 minus -7 squared plus the y value for L is 2 minus a -2 squared. That will give us, let's see here, this becomes 9 plus 7, this becomes 2 plus 2. There is 16 squared plus 4 squared. That will equal the square root of 272. Okay? Now, if you did the square root, got a decimal, absolutely fine. You should still be able to see what the concept is. Let's do MK. MK is equal to, let's see here, we need our x sub 2, so we have 0 minus 2 squared plus 4 minus a -4 squared. That will equal, 0 minus 2 is -2, so squaring it gives us 4, plus, let's see, that'll be 8 squared, 64. Let's see here, square root of 68. Well, we said this was square root of 272. This was square root of 68. This is not a rectangle. So since it's not a rectangle, it's also not a square. Therefore, the only shape we have here is a rhombus. Okay. Once again, to be a square, it has to be both a rhombus and a rectangle. All right, let's look at one more example that you might see like this. I'm going to pause the video and put the new problem up.